नमस्कार दोस्तों, स्वागत है आपका आपके अपनी फिजिक्स क्लासेस में। और आज हम आगे कंटिन्यू करेंगे चैप्टर नंबर 11 को, जिसका नाम है हमारा थर्मल प्रॉपर्टीज ऑफ मेटल। ओके, चलिए स्टार्ट करते हैं। आगे हमने कहाँ तक कंटिन्यू कर लिया था? हमने रिलेशन बिटवीन अल्फा और बीटा निकाल लिया था। आज हम जाएंगे रिलेशन बिटवीन अल्फा और गामा। ठीक है, तो अल्फा क्या था? हमारा कोएफिशिएंट ऑफ लीनियर एक्सपेंशन, और गामा क्या है? हमारा कोएफिशिएंट ऑफ वॉल्यूम एक्सपेंशन। ठीक है, तो चलिए स्टार्ट करते हैं आगे। द रिलेशन बिटवीन हमें निकालनी है अल्फा और गामा। एज वी नो दैट वॉल्यूम कैन बी रिटन एज द क्यूब ऑफ लेंथ। ओके, वॉल्यूम कैन बी रिटन एज द क्यूब ऑफ लेंथ, एंड द डेल्टा वॉल्यूम, दैट इज चेंज इन द वॉल्यूम, कैन बी रिटन एज गामा original volume into change in temperature, and change in length can be written as alpha original length into change in temperature. Now the new volume comes out to be original volume plus change in volume, that can also be written as length ka cube plus change in the length cube. Okay, so we can equate delta V as gamma V delta T, and if we take q as common, so L plus delta L can be equated as alpha L delta T. Okay, as we will solve this, we can take out L from here, it come out to be L cube, and V will be equal to L cube, so they will cancel out themselves. Now we are left with 1 plus gamma delta T and 1 plus alpha delta T whole cube. Okay, now we will solve out that we are having 1 plus gamma delta T. Then here, if we take out the cube, 1 plus a plus b whole cube, identity using it, we will get 1 cube plus alpha cube delta t cube plus 3 times of alpha square delta t square plus 3 times of alpha into delta t. Okay, and as we know that alpha is very small, so we can say that alpha cube and alpha square are very small, so they can be neglected. After getting these two terms be neglected, we will left with 1 plus 3 alpha delta t. Now 1 will cancel out with 1, and now delta t will cancel out from delta t. We are left with gamma equals to 3 times of alpha. Here we have established a relation. Here the gamma, that is the coefficient of volume, okay, expansion, is equal to 3 times of coefficient of linear expansion. Okay, and we have known that beta, that is 2 times of alpha, or alpha can be written as in form of beta by 2. And we have got gamma, which is 3 times of alpha, and alpha can be written as in form of gamma as gamma by 3. Now equating all of these, we will get alpha equals to beta by 2 equals to gamma by 3. Now after taking LCM, we come out to one conclusion, that is 6 times of alpha equals to 3 times of beta and 2 times of gamma. So this is the relation between the coefficients of linear expansion, coefficients of linear expansion, area expansion, and volume expansion. Okay, now we will study about next topic, that is thermal stress. Thermal stress is also related with what we say, these thermal expansion. Okay, so thermal stress is a type of stress which is produced. Okay, let us take a rod. We had seen, now let us take a rod with length L. Let's suppose this is a rod, okay, and this is have a length L. Now these 2 points are fixed. Its 2 points are fixed. Now there is a change in length when we will provide heat. We will heat it up, and then there will be a change in length. So let's say take delta L be the change of length. So there is an increment in the length, that will be delta L. And the temperature which is provided, the change in temperature can be written as delta T. Okay. Now as we have seen, due to linear expansion, that delta L comes out to be alpha L delta T. So we can take out this L, and we can say delta L by L equals to alpha delta T. That can be written as alpha delta T. Now as we know that delta L over L can also be known as longitudinal strain. Okay, delta L over L is the longitudinal strain, so that can also be written as alpha delta T. Okay, the longitudinal strain can also be written as alpha delta T. Now we have studied about Young's modulus in the previous class, or in previous some chapters we have studied about what the Young's modulus. So Young's modulus is what? longitudinal strain, that is thermal strain over longitudinal, so it's thermal stress over longitudinal strain. Okay, so we can now thermal stress comes out to be modulus, Young's modulus multiplied by longitudinal strain. So thermal stress can be written as Young's modulus multiplied by longitudinal strain. Now Young's modulus multiply Young, what's the value of longitudinal strain? That is alpha delta t. That is alpha delta t. Now if we have thermal stress, so stress is what? Force upon area. Stress is what? Force upon area. So thermal stress can be equated as force upon area, and if we have to find out the force developed in the rod. So what will be the force? The force comes out to be Young's modulus into delta T multiply area. Okay? Young's modulus into alpha into delta T multiply area. I thought it's, if it is not visible, it is F equals to Young's modulus alpha delta T into area A. Okay? So this is the force which will be developed due to thermal stress. So this is the force. Okay? Now we will have two more topics, that are real expansion and apparent expansion. Okay? These two are related with volumes. Just a second. We have the coefficient of real expansion of gas What do you mean by real expansion? Okay, and real expansion means that if we have a gas in a container, for example, we have a gas and that is inside a cylinder. Okay, the gas is inside a cylinder. It has gas molecules inside it. When we will heat it up, okay, when we will heat it up, the molecules are going to expand. Okay, the gas will try to expand itself. Okay, but the container is the container cannot expand here. The container is such that it do not expand, because as we are providing heat to the container, so it's real that the container will also expand. But in such situations or such conditions in which the container is not going to expand, जिसमें container expand नहीं होता, सिर्फ the real gas, that gas is going to expand, that is known as coefficient of real expansion of gas. Okay, the container is not going to expand, the only thing which will expand is the volume of the gas. Okay, so we say that change in volume over original volume into delta T, that is represented by gamma R. So this is the coefficient of real expansion. So gamma R is represented as change in the volume over original volume multiplied by delta T. Now there is another case in which we take, the next case is coefficient of apparent expansion of gas. Okay, then in this condition we will represent it by gamma A, which is delta V over V into delta T. So that is apparent change in apparent volume over original apparent volume multiplied by change in temperature. Okay, and this is change in real volume over original real volume multiplied by change in temperature. Okay, so these are the two topics. If I hope you are clear about what is real expansion and what is apparent expansion. So real expansion, the only the content or the gas which is inside the container, which we its volume will be considered. Okay, that is known as real volume. The volume of the gas only be considered. Okay, and the change in the volume is only considered. In which the other condition is where apparent expansion, in which the expansion in the volume plus the container expansion is also considered. That is known as apparent volume. Okay, so that is consisting of the volume that is inside the container as well as the volume that is of the container, and then original apparent volume multiplied the change in the temperature. So these are the two main apparent expansions of the real of the gases. Okay, that is real gas, real expansion of the gas, and apparent expansion of the gas. Okay, and we will study about, now let's have one more topic, that is a small topic, that is latent heat. We have latent heat. Next topic is latent heat. Latent heat is nothing, we will represent latent heat by L, which says that it is the amount of heat upon the mass of the substance, that is Q over M. Okay, that can be written as Q over M. So what is latent heat? Latent heat is nothing but a hidden heat. It is said to be a hidden heat. ऐसी heat जो छुपी हुई होती है, which help in changing the state of a matter. ठीक है? Changing the state of a matter. For example, we have ice cubes. Okay, the ice cubes, when they are kept outside, there is no temperature change which will take place. The temperature here is not going to change. Okay, but the state of the liquid, the state of the matter will change. So that is known as latent heat. So in which we are not about, the temperature is not able to find out, the temperature is not going to be discovered, where in the latent heat. So a heat in which the amount of heat is supplied to the mass of the substance, where the substance changes its states from solid to liquid or liquid to gas without recognition of the temperature by the thermometer. Okay, here the thermometer could not able to recognize the amount of heat that is being used by the substance to change its states from solid to liquid. That is known as latent heat. Okay, so ऐसी heat जिसका कोई मेजरमेंट टेम्परेचर या थर्मोमीटर नहीं कर पाता, थर्मोमीटर उस स्टेट का मतलब उस ऑब्जेक्ट का टेम्परेचर वेरिएशन नहीं कर पाता, बट वो जो ऑब्जेक्ट है वो अपनी स्टेट चेंज कर लेता है, ऐसे हीट को हम कहते हैं लेटेंट हीट. ओके, सो इट इज नोन एज हिडन हीट एज वेल, इसको छुपी हुई हीट भी कहते हैं. चलिए अब जो भी कुछ बच्चे 2-4 टॉपिक्स और बचे हैं जिसको हम कंसीडर करेंगे नेक्स्ट क्लास में. Till then, thank you and have a nice day.